Congratulations! You made it to part 2 of the Got Volume series. Yep, that's a 2. Remember in the first video, which of course this is about a Common Core standard, about knowing the formulas for volume. In this case we're doing cylinders. But we're using those formulas to solve problems. I taught you, or basically reminded you, about your algebra skills and how if you knew this basic formula for the volume of a cylinder, that you could rearrange that to isolate different variables. So you could solve for radius, you could solve for height, you could even solve for diameter, right? So if you missed that or landed here by accident, and that sounds interesting, go back to part 1. Okay? Here what we're going to do is actually solve this problem. Now, I want to solve for radius. Radius is buried in the middle of this formula over here. So I have two options. First, I could solve for r, then substitute my numbers, get my answer. Or, we'll color code this, lots of pretty colors. I could substitute the numbers first, just into the formula while it's sitting there. Then isolate that number, or isolate that variable and solve it. Okay? I'm going to show you both ways here because depending on how your brain got hooked together years ago, one of these might make more sense than the other one. So let's do that. I'm going to start in the blue over here. We're going to solve for r. What that means is take the equation, isolate the variable that we want here, which is the r. So I'm going to eliminate the pi and the height. Hopefully you see these, see the giant 1 there. There's another giant 1. 1 makes them go away. There's one way of looking at it. Okay, so since those go away, this creates a new formula for me. It's really the same formula, it's just rearranged. And I don't want radius squared, I want radius. So I take the root of both sides. What I end up with is radius equals the root of volume over pi times height. Okay? So I end up with this formula that's going to allow me to solve for r. Then I'm going to take the numbers given to me. I'm going to change to black now because it's a finer tip. Got r. We just recopy everything. But I've got volume of 355. Substitute that for the v. Pi, I'm going to use the common estimate. It's perfectly okay to use a common estimate of that, or 22/7 if you're dealing with fractions. Okay? And the height, which we were given up there, is 12. I'm just going to make the calculations. I'm showing each step. Showing each step is a great way to backtrack and catch your own mistake. Of course, you would never make one, but I might, so I like to show every step. Then we're going to divide these two things, saving the root for last here. You can tell this is going to be 3 something, right? I'm going to round off to the nearest hundredth, and what we get is 3 7/100. That's after rounding. For the radius, whoopsie, there we go. Okay, so first I solved for r, made this new formula, then substituted and got my answer. The other option we have over here is we're going red. I'm going to substitute all the numbers, then I'm going to solve. What? Yeah, we start with the same exact formula for volume of a cylinder. Now let's do some substituting. I was given the volume. We're just leaving it just like this. We're substituting first, then solving. I'm going to take the 355. We're going to take the common estimate of pi. We're solving for radius, so we're going to leave that. But we were given the height of 12. Okay? Now, since I want to get rid of... Now you can rearrange this stuff. Check this out. You have magical powers if you've been through algebra class, okay? you can rearrange this. Multiplication is commutative. So why not put the 3.14 and the 12 over here, right? So you can see that it's obvious. You can multiply those together. I mean, you could do this now or you could do it later. I prefer now over later in most life transactions. Here we go. So we have, wow, how'd you do that so fast? Well, I didn't really. We just already knew the answer, right? It came from over there. Okay, and then we're going to, that's the coefficient of the radius squared. So we divide both sides by that. Are you having flashbacks from algebra? I hope so. Okay, now we're just going to begin this isolation process here. Oh, is it looking familiar? I hope it is. Side-by-side comparison. Do you see how this is the same? We're going to get the same answer. But let's go through the steps. To find that side of the square, we take the root of the square, right? The side of any square is just called the root. And we're going to take the root of that, which leaves us with a single r and 3 7/100. That is sweet. I'm going to zoom out so we can fully appreciate the artwork that just happened. Okay, so your choice. You can solve for the desired variable by isolating it and then substitute, or you can plug the numbers in first and then just isolate the variable later. Either way, we end up at the same place with the same answer, and that's going to do it for this one. Now, if you'd like to practice solving for other variables such as diameter or height, please tune in to Volume 3. Get it? Volume 3 of Got Volume, where we're going to explore a couple of practice problems and put this into action on the practice field. Okay? So thanks for watching. Subscribe to whitchermath, and I'll see you later. Thank you.
Volume.